One of the most powerful supercomputers in the world has now been fully installed and tested at its remote, high-altitude site in the Andes of northern Chile. This marks one of the major remaining milestones toward completion of ALMA, the Atacama Large Millimeter submillimeter array. The ALMA correlator turns ALMA's many antennas into one giant telescope. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. ALMA is the most elaborate ground-based telescope in history and is composed of an array of 66 dish-shaped antennas. Its supercomputer, or correlator, is a component of crucial importance. For ALMA to work, the faint celestial signals collected by each antenna must be combined with those from every other antenna. The correlator's processors will continually combine and compare the data from up to 64 of the antennas in the ALMA array, which are separated by up to 16 kilometers, enabling the antennas to work together as a single enormous telescope. The ALMA correlator has over 134 million processors and performs up to an unbelievable 17 quadrillion operations per second. That is 17,000 million. The correlator was built specifically for this task, but the number of calculations per second is comparable to the performance of the fastest general-purpose supercomputers in the world. This unique processing challenge needed innovative design, both for the individual components and for the overall architecture of the correlator. The initial design of the correlator, as well as its construction and installation, was led by the US National Radio Astronomy Observatory, the lead North American partner in ALMA. The correlator project was funded by the US National Science Foundation with contributions from ESO. As the European partner in ALMA, ESO also provided a key part of the correlator. An entirely new and versatile digital filtering system, conceived and built in Europe, was incorporated into the initial NRAO design. The University of Bordeaux designed and built a set of 550 state-of-the-art digital filter circuit boards for ESO. With these filters, the light that ALMA sees can be split up into 32 times more wavelength ranges than in the initial design, allowing astronomers to flexibly slice and dice the spectrum of light. As well as enormous technical challenges in building the correlator, the extreme location of the system was also a factor. The correlator is housed in the ALMA Array Operations Site Technical Building, the highest altitude high-tech building in the world. At 5,000 meters altitude, the air is thin, meaning that twice the normal airflow is necessary to cool the supercomputer. The thin air also makes it impossible to use spinning computer disk drives, as their read-write heads rely on a cushion of air to stop them crashing into their platters. Furthermore, the correlator had to be designed to withstand earthquakes, which are common in this region. ALMA began science observations in 2011 with a partial array of antennas. A section of the correlator was already in use to combine the signals from these antennas, but now the full system is complete, ready for ALMA to begin observations with a larger number of antennas. The successful installation of the new supercomputer marks an important step toward the completion of ALMA in the near future. By using the array's unparalleled observational power, scientists will gain new insights into the hidden wonders of the universe. On the 13th of March 2013, in a remote part of the Chilean Andes, the official inauguration of ALMA, the Atacama Large Millimeter submillimeter array, took place. This ceremony marked the completion of all the major systems of the telescope and its formal transition from a construction project to a fully fledged observatory. The President of Chile, Sebastián Piñera, and many other high-ranking officials honored the event with their presence. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. ALMA is the world's most powerful tool for observing the cool universe. ALMA is not a traditional telescope, but an array of 66 antennas spread out over the Chaknantor Plateau with separations of up to 16 kilometers. The antennas are linked and their signals combined so that ALMA can work as one single giant telescope. This allows astronomers to make observations with unprecedented sensitivity and resolution. More than 500 people gathered on the 13th of March in the Chilean Atacama Desert to celebrate the success of the ALMA project. The guest of honor was the President of Chile, Sebastián Piñera, who was accompanied by high-ranking politicians and officials. Amongst them were representatives of ALMA's international partners from Europe, North America and East Asia, as well as representatives from Chile, ALMA executives, personnel and members of neighboring communities. The event was covered extensively by press and media from around the world. The inauguration ceremony had several speakers. The ALMA director, Thijs de Grauw. ALMA chief scientist, Ryohei Kawabe. Subra Suresh, director of USA's National Science Foundation. Tero Fukui, Senior Vice Minister of Japan's Ministry of Education, Culture, Sports, Science and Technology. ESO Director General, Tim Deziu. Finally, the President of Chile, Sebastián Piñera, addressed the audience. The highlight of the inauguration ceremony was when the President of Chile gave the ALMA scientists and operators the command to initiate science observations.
Adelante, Antonio.
Apuntar ALMA al centro galáctico.
many other activities were also part of the celebrations. The visitors to the ALMA observatory explored the facilities high on the Chaknantor Plateau at an altitude of 5,000 meters above sea level, and experienced for themselves the harsh conditions at the array operations site amidst the volcanic peaks surrounding the antennas. They learned more about the workings of ALMA at the operations site facility where the telescope is operated and the ALMA laboratories are located.
So this part of the assembly is what first picks up the photon on the antenna.
Yeah.
The assembly of ALMA's 66 antennas was recently completed, with the last batch of 8 currently being tested before entering into service. A partial array of antennas is already available to astronomers worldwide and is generating impressive scientific results. The history of ALMA science began with the release of a picture of the colliding antennae galaxies. Visible light can only see the stars that make up these galaxies, but ALMA revealed the clouds of cold gas from which new stars are born. The inauguration of the Atacama Large Millimeter submillimeter array marked the beginning of a long journey. A journey that has aroused great expectations. A journey toward breathtaking discoveries. A journey into the unexpected. A journey to our cosmic origins. High on the desolate Chaknantor Plateau in the Chilean Andes, one of the harshest environments on Earth, amid volcanoes, desert plains and bitter winds, ALMA, the Atacama Large Millimeter submillimeter array, is ready. Astronomers and scientists all over the globe have been eagerly anticipating this moment for decades. ALMA is the world's largest astronomical project, but it is not a conventional telescope. Instead of collecting and analyzing visible light, it looks in a different and largely unmapped part of the spectrum. By opening a new window on the cosmos, ALMA explores one of the last frontiers of astronomy, the cold and distant universe. All in search of answers to some of the deepest questions about our cosmic origins. How do stars and planets form? How did the first galaxies form? The Chaknantor Plateau in North Chile. Despite the literally breathtaking altitude of 5,000 meters above sea level, ALMA has flourished. Over the last few years, more than 50 antennas have been installed across the high desert plain. ALMA is a unique giant telescope built in a partnership between Europe, North America and East Asia in cooperation with Chile. 66 state-of-the-art antennas will observe the universe at millimeter and submillimeter wavelengths, 1,000 times longer than visible wavelengths. This light reaches us from some of the coldest and most distant objects in the universe. Water vapor in the atmosphere blocks these faint whispers from the hidden universe. So, to collect them, we have to go to an extremely high and dry site, like Chajnantor. The origin of the ALMA project dates back decades. Scientists from Europe, North America and East Asia developed 3 individual concepts for new large telescopes for millimeter and submillimeter observations. Eventually these concepts were merged into one. Big science takes big global collaborations. Together, countries can achieve what they cannot do alone. The whole is greater than the sum of its parts. The ALMA project was born. This new telescope needed a home, and eyes turned to Chajnantor. Every aspect of the site, from the astronomical to the meteorological, was thoroughly tested and the atmosphere monitored daily. The conclusion? Chajnantor was the perfect place for ALMA. Construction began in 2003 with the groundbreaking for ALMA's array operations site. Conditions here, at an altitude of 5,000 meters above sea level, are harsh and very challenging. Strong winds, low temperatures, intense ultraviolet radiation, and a desperately thin atmosphere. So thin that, to work here, people need supplementary oxygen and have to undergo rigorous health checks. The production of ALMA's antennas has been shared between the 3 ALMA partners. 3 prototypes were put through their paces at the ALMA test facility on the Very Large Array site in the USA. The 66 antennas on the high plateau are a critical part of ALMA. Their big dishes collect the faint millimeter waves from space. These antennas are truly the state-of-the-art. Their surfaces are accurate to much less than the thickness of a sheet of paper. They can move precisely enough to pick out a golf ball at a distance of 15 kilometers. And they must survive, exposed to the elements on Chajnantor. "25 antennas have been provided by the European Southern Observatory, 25 by the US National Radio Astronomy Observatory, and 16 by the National Astronomical Observatory of Japan. In a truly global endeavour, The antenna components were constructed in several locations around the world, sent to Chile to be assembled, and then tested at the Operations Support Facility in readiness for their first time observing the sky. The first ALMA antenna was accepted, and shortly thereafter, 2 antennas were successfully linked together. Detectors in each antenna register the finest nuances of the faint signals collected by the dishes. These detectors are the most sensitive of their kind and are cooled using helium gas to just 4 degrees above absolute zero. The first completed antenna makes its way up to the array operations site. 2 custom-built transporter vehicles, Otto and Lore, move the 100-ton antennas around. Otto carefully climbs the winding road, carrying the high-tech antenna up to its final home on the high plateau. This first antenna was soon joined by many more. The first observations using 2 and then 3 antennas in unison were made. Key tests for the ALMA array, and all passed with flying colours. Millimeter and submillimeter wavelengths give astronomers a unique window on the universe. But to see them with the sharpness astronomers need, a single dish telescope would have to be kilometers across and impossible to build. Instead, ALMA uses 66 separate antennas, which can be spread out over the plane with separations of up to 16 kilometers. The antennas are linked and their signals combined. The result? One giant telescope, as wide as the whole array, observing with unprecedented sensitivity and resolution. Making sense of these intertwined signals takes the highest altitude supercomputer in the world. With 134 million processors performing 17 quadrillion operations per second, as many as the fastest supercomputer in the world, the ALMA correlator on Chaknantor combines and compares the signals from every antenna. As more and more antennas arrive at Chaknantor, the Operations Support Facility, the control center of the observatory, takes shape at the slightly more hospitable altitude of 2,900 meters. The site is busy around the clock, operating the telescope, testing and maintaining antennas and other equipment, and home for the ALMA staff during their day and night shifts at the observatory. In the capital of the host nation, Chile, the ALMA Santiago central offices were built. Here, the technical, scientific and administrative staff of the joint ALMA office is working. Even before the construction stage was complete, the first scientific observations began with a partial array of antennas. ALMA had opened its eyes. Thousands of scientists from around the world competed to be among the lucky few to use the facilities first. Even with just 16 antennas, ALMA was already the most powerful telescope of its kind. The first scientific observations fulfilled everyone's hopes. The antennae galaxies, a pair of colliding galaxies with dramatically distorted shapes. Visible light can show us the stars in the galaxies, but ALMA reveals the clouds of cold, dense gas from which new stars are born. The heart of the distinctive galaxy Centaurus A. ALMA peers through the opaque dust lanes that obscure its center. A view of the nearby star Fomalhaut provides clues as to how planetary systems form and evolve. Cosmic dust grains found around a brown dwarf suggest that rocky planets might even be more common in our universe than we thought. Sugar molecules spotted around a young, sun-like star for the first time. The building blocks of life in the right place at the right time to be part of new planets forming around the star. An unexpected spiral structure in the material around the old star, R Sculpturus, revealed the secrets of this dying star. Vast streams of gas flowing across a gap in the disk of material around a young star. A key stage in the birth of giant planets, observed for the first time. And all this before the array was fully complete. ALMA's inauguration celebrates its coming of age. The journey has been a long one. ALMA has grown from an idea to a construction project to a fully operational observatory and to a truly global scientific partnership. In the serene and lonely beauty of the Chilean Atacama Desert, ALMA is ready for the future. By using this marvelous telescope, the world's astronomers will peer deep into the hidden secrets of the cosmos, in search of our own cosmic origins.